Here at Cornell, we have been listening to the sounds and vibrations of soil-dwelling invertebrates, and we've been doing this both in a field and a lab context. And today I'm going to talk to you about a USDA-funded project that we've recently had funded. And this project is broadly about monitoring soil-dwelling invertebrates, and I'll talk about just one fraction of it today in my slides. So as I said, we're focused on listening to soil animals, and we're particularly interested in managed turfgrass systems. So one of the focuses of our lab is managed turfgrass, such as golf courses, cemeteries, playing fields, things like this. And within this, we're specifically interested in pest species that cause damage to the turf that need to be managed. So on the slide, I've just put the family of scarab beetles, and we're particularly interested in all of these species, and I've shown the adults here at the bottom, and their associated grub forms at the top here. And we're interested in these because the grubs feed on the roots of the grass and cause extensive damage to the turf. And so this is one aspect of turfgrass, the turfgrass systems that we're particularly interested in. So we have in the top left here, we have a grub situated in the soil, and as I said, it's feeding on the roots of the grass and causing damage. But that damage is further compounded by the predators of these grubs whilst they're digging for the grubs. And we call this grubbing activity, of these damage caused by these predators searching for the grubs. And you'll likely have seen this in your own lawns and your backyards as well. This is very common. So the photo at the bottom left, you can see the turf has been ripped up, the roots have been broken, and the grass is obviously kind of ruffled and damaged by the searching behaviour. And on the bottom right, this is another example by a different predator where you can see more localized damage. You can see these holes in the turf where, again, they've damaged the turf looking for those grubs in the soil. And so this is a problem in all different turfgrass systems. Firstly, because it's very costly to repair. You have to remove the turf, replace it with fresh turf. And in systems such as golf courses and playing fields, we want our turf to be as pristine as possible because that affects our playability on those substrates. And of course, for homeowners, it's very unsightly and it kind of ruins the lawns, and especially in the US, people like their pristine lawns, which I've learned a lot about recently. So what we have then is this need to manage both the below ground insect grubs, but also their predators. And which predators am I talking about? Who is responsible for this damage? Well, I'm no vertebrate expert, but thankfully the perpetrators appear on a checklist of American animals that I was given by my sister when I moved to the States. And so the perpetrators in this case are the North American raccoon and the striped skunk. And these both cause this turf damage when they're foraging. And other animals do too, which I won't talk about today, but birds such as the American crow and various species of gulls also damage the turf in this way. But the management of skunks and raccoons involves trapping and removing them from areas. Again, this is costly and needs specialized professionals, and these can also carry diseases as well. And these management strategies aren't always successful because typically they'll be relocating the animals, but then those animals will make their way back to their home ranges again. So these are temporary solutions. So what do we know about these species? Well, we think both utilize sound and vibrations to some extent, although I know the literature base is fairly sparse on this. We know that raccoon paws are sensitive to vibrations, and we know that they produce airborne vocalizations. Less is understood about skunks. We know that they make, again, airborne sounds, and they also have a stomping behavior where they stomp on the ground during aggressive behavior and territoriality. What we do know for sure is that both species are extremely accurate with localizing their below ground prey. So they'll go directly to a spot on a lawn or a playing field or wherever. they will directly dig, and typically they would immediately find a grub. So this is highly localized foraging behavior. And to do this, we suspect they use, of course, a combination of different environmental cues, so olfaction, perhaps substrate-borne vibrations, airborne sound, and tactile cues to locate that prey very accurately in that system. And this is really where our project comes in, because what we're interested in is whether vibrational cues play a role in this foraging behavior. And within our applied context, why we're interested in this is whether, if they are using vibrations, whether we could manipulate the vibrations and interrupt that prey-predator system, leading to kind of a potential management solution to reduce that turf damage in these systems. So in this project, we'll be investigating these cues. And to do this, we're going to be undertaking playback experiments in the field. So the diagram here shows our proposed setup, which will consist of tactile transducers buried in the ground. And these will be playing back either actual recordings of white grubs feeding, which produce these like impulsive signals, or will reproduce synthetic pulses, one or the other. And then above our plots, which will have the transducers in, we'll have trail cameras. And these will tell us which of these meso-mammals are foraging and to what extent they're foraging in these patches. And then, of course, because we'll leave these playbacks running overnight, we'll be monitoring the levels of playback and making sure that the playback actually occurs when we're not there, using sensors that we'll leave in position. So our field site for this work is Greenwood Cemetery in Brooklyn, New York City. It's around 470 acres. It's New York City's largest urban grassland. And the management strategies here are known for sustainability and for preservation of the green space. For this reason, there is no chemical control of insect grubs in the ground. So this is great for us because we want as many hotspots of these grubs as possible below the grass. Not only that, it's extremely good for playback experiments because although it's in New York City, they very carefully manage vehicle and pedestrian access, and they pride themselves in having, as you would expect, a very quiet, pristine space, which is ideal for playback experiments. And finally, because we have these extensive areas of grubs around the site, the area attracts raccoons and skunks. And so there's a very large population of unmanaged raccoons and another similarly large population of skunks. And these forage both on the edge of the cemetery going into the city, but also right in the center where we have more biological diversity as well. So there are different strategies for managing the cemetery. So some areas are mown and kept very pristine, and other areas are kind of semi-wild. And so I'm just showing you a photo here of one of these areas which has actually minimal management from people. But you can see again this turf damage at the front here, where the turf is visibly browned and ruffled. And so in the context of a cemetery, this is a problem for a number of reasons. Again, as I talked before, it's costly to repair this damage to the turf. And visitors to cemeteries often kind of expect this pristine environment where everything looks very neat and tidy. And many people kind of think it's disrespectful for those at rest to have these kind of untidy, unsightly looking areas around grave sites. And so there's this need to manage this turf damage in a low-cost way, again, within these themes of sustainability and not using chemicals and things like this. So this makes Greenwood Cemetery a really ideal site for our proposed work. Going into our experimental plan, so our playback experiment will be a number of different treatments. And I should say here that this is very much kind of flexible at the moment as we're still really in the planning stage, but it will essentially be different combinations of vibrational signatures, such as silent controls, white noise, and grub playbacks, in addition to combinations of physical grub presence or absence. And so I put a diagram here just to kind of help you visualize. And this slide is, again, very much work in progress, but at the top here I've written our potential treatments. So whether grubs themselves are present in absence, and then different vibrational treatments such as white noise, recordings and silence, and then kind of dummy treatments such as having the electronics present but not necessarily running, to ensure that those themselves don't influence the animals. And so our current plan for the work is at the bottom of the slide. And so what we're proposing at the moment is something like 4 treatments listed here, and we have enough equipment to have 5 of those experiments running per night. And the idea would be we'd run this over multiple nights, and we target this in particular areas of the cemetery where we know these animals are actually foraging. So what might that look like in practice? So here I've got this diagram, and you can see the yellow boxes. These would be our experimental plots. And so these would not be visibly marked, well, only with kind of turf paint, nothing too major, but they'd be about 0.5 meter to 1 meter squared plots. And this is where we'd be assessing turf damage after the playbacks. And so we'd have a number of these plots. Each of them underneath the grass would have a buried transducer, and these would all lead back to the centralized electronics box that would oversee everything. And then we'll have these 2 trail cameras. I've got one shown here at the top left and the bottom right. And these would oversee the plots to monitor which animals are arriving and what they're doing when they start foraging. And this would be all battery powered and would run for a number of days. So in terms of experimental timings, we start here on the left. At dusk, once all of our equipment has been deployed, we would be turning on our cameras. We'd start our playbacks, and they would run through the night, and hopefully we would attract foragers during that night time. And so they would be foraging in this window of time in the night. And then in the next day, we would go back and we would assess the damage to the turf. So we'd score the amount of digging per plot, and we'd use quadrat sampling to assess percent damage in each turf plot. And of course, we'd be checking our cameras and then replacing batteries. And then at the following dusk, we would repeat this again. So that's essentially how the experiment will run. So in the fall, we completed some trial deployments of the equipment, basically just to test the feasibility of the idea and how easily it was to deploy the equipment. So we deployed in a turf research farm in Ithaca, close to us here. And so if you look at the top photo, I've drawn on here in orange where our plots are, because they're quite hard to see in the photo. But here I'm showing 2 plots, and each of those have our transducers buried beneath. And we have the cables laid in trenches, totally hidden, also in that photo. And the idea behind this is that raccoons particularly are extremely curious, and so we need to hide as much as of our electronics as possible. In the photo below, you can see 4 plots, and they've got orange markers on the corners just to show you. And you can see 2 trail cameras are marked on stakes, and they're overseeing those plots. And we have just 1 electronics box, which probably in the final experiments would also be buried. So there's a lot of kind of burying everything to make sure we're as hidden as possible. And so this is a still of the ideal type of footage that we would want to see from our trail cams. So we want our foragers to be visible and foraging in our plots so that we can assess the damage the next day. In our test deployments so far, we haven't had much of this footage. We've had a lot of this kind of footage of deers walking in and out, and of course various people maintaining our turf systems. But as I said, so far our deployments have largely been just to test that everything works and that everything that we bought is working properly. And now we're in a stage basically where obviously winter has come, so our grubs are deeper in the ground and they won't become active again until the spring. So now we have some time to really iron out our experimental plan and our treatments. And whilst we have all our equipment, I still feel like there's a fair amount of planning to do before we do those spring experiments. So that's really an outline of our project. And what I'd really like to do is get everyone's feedback specifically on this project. But also what I thought would be really useful to do is to talk about playbacks in field systems much more broadly. So I've made a summary table here, and this is actually from one of the book chapters from Studying Vibrational Communication, and I've just outlined here all the possible problems and solutions for doing good playbacks in the field. And so I thought I'd just talk about each of those very briefly here, and then I'm hoping we can all kind of talk about these more broadly as well at the end. So first up, on the first row here, we're very keen to have our playback signal be representative of what we want to reproduce. And so to do this, we will need to pre-filter the signal or use some artificial signal. And this is actually the main point I'd like to discuss with everyone, because I know there are MATLAB scripts for pre-filtering the signals, but I haven't done this before, and I'm keen to know if anyone's been doing it in other ways or could advise me on the best ways to do this. Because I'm very keen that our playback signal is representative of our grub movement and feeding signals. Next up, well, the next 2 points regards temporal characteristics of signal and amplitude calibrations. The next point that I would like to discuss is the effective substrate, because although we'll be in the field, we'll be in natural soils, obviously, soil itself varies a lot in terms of moisture, compaction, temperature, all of these things which would affect vibrational propagation. And so currently my thinking on this is that we would basically just work in as many different areas across the site as possible. And we would include, we would measure the substrate itself and include substrate physical factors in our model. But I'd welcome any other feedback on that. Some of the last two aspects I think are kind of almost out of our control. Environmental noise. Of course, we're aware of doing playbacks during wind and rain events. Our timing, we can time our field trips to the city with the weather, but once we're there, we're kind of there. So we can adjust this a little bit, but not a massive amount. And the final one is the mobility of our subjects. As they move around the site, they're going to be receiving slightly different vibrational stimuli. I am not sure quite how to deal with this, in a sense that the nature of the project means that these animals have to be free ranging. We wouldn't want to enclose them in any way. So what I was thinking is I could measure across each grub hotspot area the vibrational signals and work out what they may receive as they approach the areas before they start digging. So that's just whistling through that table, and that is the end of my slides. So it'd be great now to get some feedback from all of you and then maybe return to that table in our discussions.